Hello all. In the series of doing SAT topics, this is our next video where we will learn about working with functions. So first of all, we will see what is functions. So basically, function is set of relation, like a set or a relation called to be a function if every input has a single output. Here what I mean by every input has a single output is, see, for one input we can have one output, like more than one input. Suppose there are many set of inputs, they all can have same output, but one input cannot have more than one output. One single input cannot have more than one output, but different inputs can have the single output. Then next is for example, if we take this mapping diagram, suppose this is set A, this is set B. Set A contains 2 3 9, set B contains 5 7 1 4. So 2 is mapped to 5, 3 is mapped to 7, 9 is mapped to 1, and suppose 3 is again mapped to 4. So you can see same input we are having two different outputs. So this is not a function. Now if we will take another mapping diagram, another set of mapping diagrams, so suppose this is P, this is Q, where P has 1 5 9 10, and here we are having 2 4 7, where 1 maps to 2, 5 maps to 4, 9 also maps to 4, and 10 maps to 7. Here you can see two inputs are mapping to the same output. So this is a function. Then in function we have to do a vertical line test. If it's given a graph, then what we do? Vertical line test. A function passes the vertical line test. So what is vertical line test? First we will see the definition. So if a vertical line passing the graph at only one point or at no point, then the graph represents a function. If the vertical line will intersect any graph more than once, that means that will not represent a function. For example, if we take, then suppose I'm taking a pair of example where one will be a function and one will not be a function, and I'll take parabola for both. Here if we take a vertical parabola, this is y-axis, this is x-axis. Here if you will draw any vertical line, then that will either not intersect at any point or intersect the curve at only one point. But here if we will take a horizontal parabola like this, any vertical line will intersect at 2 points. So you can see, since it is intersecting at 2 points, so it will not be a function. So this is a function, this is not a function. Next we have to learn in this topic is domain and range of functions. Domain and range. Domain means all set of inputs and range means all set of outputs. Now if we talk about the domain, then there are some specific rules for finding the domain and range of some types of functions. For example, first, for any rational function, denominator can't be 0. We use this rule to find the domain and range of a rational function. Then second, a square root radical, basically square root radical function or any even radical function, not only square root but any even radical. The expression inside the radical, which we basically called as radicand, should be non-negative. And if we talk about range of a square root radical function, then a square root cannot give negative numbers, so it will be again greater than equal to 0. Number 3, if we talk about, see, these two are the basic rules of finding domain and range. Now if we talk about any polynomial function, then if the polynomial function is like odd degree polynomial function, then it will have domain and range both has all real numbers. But if it is even degree polynomial function, then domain will be all real numbers but range will not be all real numbers. But if there is any transformation involved, then it can have the negative numbers. But with parent function, it will always be only positive numbers. So these are the basic requirements for domain and range. Now let's see question on domain and range. So suppose we have fx equal to 2x minus 3 over x plus 1, and we need to find the domain and range of this function. Then what we will do here, for domain, as I said, denominator cannot be 0 in a rational function. So we can say for fx to be defined, x plus 1 should not be equal to 0. This implies that x cannot be equal to negative 1. So from here we will be getting belongs to all real number except negative 1. Now what we will do, let y equal to 2x minus 3 over x plus 1. So what we will be getting, if we cross multiply, then we will be getting xy plus y equal to 2x minus 3. This can be written as yx minus 2x equal to negative y minus 3. So this implies that we can take x common. So y minus 2 is equal to minus y minus 3. So we can write x equal to minus y minus 3 divided by y minus 2. Again we get a rational function in terms of y. So what we will do now, this to be defined, y minus 2 should not be equal to 0. This implies that y cannot be equal to 2. So we can say range will be, see, that was one of the representation. We can also write in this way, y belongs to negative infinity to 2 union 2 to infinity, or we could have written in that way also, y belongs to r minus just 2. So y belongs to all real numbers except 2. So this is how we will be finding the domain and range of any rational function. Now next topic which we have to do is inverse of a function. So finding the inverse of a function, there are some steps which I'll explain with an example. For example, we need to find inverse of fx is equal to 2x times, or we can say 2x over 3x plus 2. We need to find the inverse of this. So what we will be doing here, right, y equal to fx, that is the step 1. Then step 2, when we will be writing this, first let's complete step 1. So y equal to 2x over 3x plus 2. Number 2, exchange or swap, whatever we say, the places of x and y. So we'll be getting x is equal to 2y over 3y plus 2. Now what we will do, number 3, find y in terms of, so what we will be doing now, just like we did in finding the range of rational function, we will cross multiply here and we will be getting 3yx plus 2x equal to 2y. This can be written as 3yx minus 2y equal to minus 2x. This implies that we can take y common and we can write 3x minus 2 equal to negative 2x. So this implies that y is equal to minus 2x over 3x minus 2. So this is the inverse function only. So we can say f inverse x is equal to minus 2x over 3x minus 2. This is how we can find the inverse function. Then we will talk about exponential functions. So in exponential functions, we basically, exponential function is given by y equal to a b to the power x, or we can simply write a to the power x. So how it is graphed, the graph of this function, this is y-axis, this is x-axis. So this is the graph of y equal to a times b to the power x when b is greater than 1, and when b will be less than 1, then how it will be there, it will be like this. From this side it's like this. This is the graph when b is between 0 and 1. Now when it becomes negative, then we will simply take the reflection, which we will study in transformation of functions. So next is growth function or decay function. Growth function, decay function. So growth function is written as y equal to a times 1 plus r to the power x, where r is the rate of growth, and decay function is written as y equal to a times 1 minus r to the power x, where r is a number between 0 and 1, because that will always be given in decimals. R is rate in both the question, both the types. Here it is rate of growth, here it is rate of decay. Now next is transformation of functions. So in transformation of function, this is very important topic in function. So basically we get some type of transformation. We will first start with translation. Suppose y equal to fx is the parent function we are taking. So translation, it can be either horizontal translation or vertical translation. So if we talk about horizontal translation, then we can say y is equal to f of x plus h. Now here two conditions are there. If h is greater than 0, then shift left by h units. If h less than 0, then shift right by h units. Number two, sorry, this was horizontal translation only. Then we will talk about vertical translation. In vertical translation, it's given as y equal to fx plus k. Here it's simple, k greater than 0, then shift up by k units. If it is k less than 0, then shift down by k units. Next, number 2 is reflection. So in reflection, if it is y equal to f of minus x, then reflection about y axis. If y is equal to minus fx, then reflection about x axis. Number 3, dilation. So number 3, dilation, where it is given by both the types of dilation will be there, vertical dilation or horizontal dilation. And in again vertical dilation also it will come either stretching or compression, and in horizontal dilation also it will come stretching and compression. So if it is y equal to a times of fx, that if any constant is multiplied in the function, then vertical dilation. So vertical dilation means here if a greater than 0, if a is greater than 0, then we get compression. Sorry, not a greater than 0, it's greater than 1. If a is less than 1 but greater than 0, it stretches. Next is y equal to f of bx. Then horizontal dilation. In this one, if b is greater than 1, then it stretches. If b is between 0 and 1, then there is a compression. So that's all in function. For more video of this SAT, continue with our channel, and also for detailed courses in AP, AMC, ACT, SAT, please join MLS classes where we cover all these topics in details. So thank you for watching this video.